Why didn't you utilize this UUID for the same Sadhana referral?
I could not get you.
UUID.
You can use this in the same problem, right? You can have explained it there. Why not explain there?
Okay, yeah, if I would have explained that in that same lecture, then it will become like a
Oh,
2 hour
very
thing.
long. Oh,
So it will be hard to grasp.
got it, got it.
Yeah, like we have another thing that we need to explain there. That is this hash functions.
Hmm.
So that should not be like included. Otherwise, it will become very big.
Yeah, people may last, right?
Yeah, lost. Yeah. So unique ID generation in this thing, we have some like I have some questions from you guys. What things you wanted in this? Like as the name suggests, it should be unique. That should be the first one. Oh, unique. Then what should ID should have? All numeric. Keep it simple. And we can take like ID should be ordered by date. Not should be like incremented by one or two. Then ID ID must be 8 bytes, 64 bit. Then what other thing we can see here? Per day, how many IDs we need? Let's take per day we need per second we need around 10,000 IDs. 10,000 unique IDs per second. Okay. So this is some prerequisites that I think we should keep in our mind. And as in our last chapter, we discussed that UID can be kept in different way. Okay, like a database also generates a unique ID. Those are like we can take like time based database where a unique ID gets generated. But when you use single database, then it's fine to use it. But if we can take an example like we have like 10,000 per second, and it will reach 36 in like 1 year. It will reach around 3.6 terabyte. So it will be a very big database and single point of failure if we kept in a single database. So that's why we have some different approaches for that. Like first one we can say multi master replication. We should replicate into multiple one. So in multi-master application, you can see like we can say we have multiple databases at different data centers, because in distributed system, availability is one of the part, and whenever their data centers are at multiple places, single point of failure will be out, and like not single, like it is like a permanent failure, that Markle tree that we have discussed earlier. uh, you can think, if we keep in different data center, when one data center goes out, the others will keep incorporate it. So here what things could be complicated. The pros of this one is like we can use the database timestamp, which is auto generated. So every time it will add an entry, it will be unique. Okay. Now the cons are like, uh, when you have different database, when two different DBs are generating, we should have a synchronization mechanism so that they are familiar with each other, that they should not generate the same ID again and again.
Same timestamp should not be there.
Yeah, same timestamp should not be done. So there is a solution for that. What solution it suggested? I gave one simple drawing here. Like these are database 1 and 2, and this is our server. This is UID server. Then this is DB1 and DB2. So like this, we have key numbers of DBs, n numbers of DBs, okay? And you can think like, yeah. So how they will generate numbers? They will add n to their generation every time. Okay, like this DB, it will generate 1 plus, there are 2 DBs here included, so we will add by number 2 here. This 3, then 5. It will generate 2, 4, 6. So like this, those are unique. Okay, as these are in the same cluster, they will generate the unique one.
Means one server is generating odd number, another generating even number.
Yeah, correct. And if it's increased by number in n, so then every time it will change. Now here, what is the hard part? And there is a server in center. They will keep sync with the center server. Okay. Now what is the problem with this? One is, like I have said, in the different data centers there will be same numbers of database, and they could generate same IDs by this approach. And so that is one con is there. And the second is like, if we add 1 dB or remove 1 dB, the numbers get changed. We have to like track back again everything, because removing one, like n minus 1, will like now start generating other things. Same server will start calculating now the different IDs patterns. That could be repetitive. Okay.
Yeah. Yeah.
And another thing is like we have kept one option here. The ID should order by date, okay, or time. But this is not by time; it is by number.
Hmm.
So that is like easily crackable. So that's why we will find go to another method, another approach, that is UUID. And this is unique ID only. This is UUID pattern, huh? UUID pattern. What it leverage? It leverage the system actually. Like our kernel, they provide some unique IDs, and while interacting with the CPU, they will create a number. Okay, and that number is unique, and we can use that also. Like every DB can keep that number from the its own server, and it solves a major problem that we have here, like the collision. And we have to keep the sync, and we have to maintain, in the earlier one we have to maintain a synchronized central server that will keep track of everything. And the second thing, that if a DB is removed or added, then there is a complexity is there. Here what it breaks down: UID, like you have here three servers. So in this you can see this is like server 1, or this is DB1. Then it has its own server named as S1, and this is like S2, and it has its own DB2. And if you can take this as an example here, it is like DB3. It has its own S3. Okay, so all these servers will generate one unique ID and save it to its database. So they are not like connected to each other, and there is no synchronization needed, and there is no collision in between them, because each server will generate its own timestamp, and that will be unique to that database. The problem here is the number that gets generated is 128-bit and alphanumeric.
Are you reading, Kankan?
Sorry?
Are you reading notebook?
No.
अच्छा.
चलो ये मैं रिकॉर्ड तो हो ही रहा है, ये सब बीच में नहीं पूछना चाहिए ऐसे. ठीक है. 128-bit or alphanumeric, okay, and these are like cons here, okay, and these are like S1 is generating its own. They all have a generator of their own, UID generator, and they will save to D3, D1, D2, and these are not time based again, okay. This is not increment by a time; they are increment by some logic, so they are not ordered. but it provide us some solution, better solution, like it is easy to scale, like you can easily increase database and servers, and there is no synchronization needed, so data center problem is also solved. Just the problem is more memory needed as it's 128-bit. And another solution that bring up here, ticket service, like this is almost similar to this one. This is main ticket server, and all these DBs are generating its own. Here we have DB plus server, and this is DB plus server. So one ticket service which will, like what it will do, it will keep generating the IDs and saving it to each DB, and like uh, all those are in syncs, like in each DB it will save another ID, or it will keep sync of all of that, like this one single point we kept at here, and we will distribute this in all the DBs. But what is the problem with this one is that as this one is a single server, if it's got fail, all the DBs will of no use.
Hmm.
So this is the bottleneck here for this. This is single point of failure. No? So that's why this is the second method that is also sometime useful, but it is not a production ready method. And final one is that suggestion that up. It came up to the uh, Twitter. What Twitter has did it, they for generating their unique IDs, they broke this down. They broke down this service into they broke down this 64-bit, or divide this in a fixed patterns. What patterns they have introduced, like you can see.
This is the number of column wise selecting. If you want 10 columns, you can select there. That will one row and how many columns. If you
Yeah,
need
I
this,
need one row only.
okay.
So what they have divided, they divided it into four parts. Sorry, five parts. Like first one is optional. Okay. Then second, they will keep the timestamp. This is of first optional is of 1 bit, and this timestamp will be around, I think, 41-bit. And then they have kept they kept reserved this for data centers, 5-bit, and then they keep for DB, number of DBs per data center, another 5 bit, and at last they kept a sequence generator. Okay, they kept it 12. So you can see here 41 plus 1, 42. 42 plus 10, it will 52, and 12 64 bit. So they divided the 64 bit in this way, so that the data center can have 2 raised to power 5 around 32 data center they could have, and like around 32 dBs per data center they can have. This one is like reserved. They will keep 0 here. It will maybe in for future use. And this is the timestamp that 2 to the power 41 combinations can be generated here. And this is the final one. It is the sequence. That is 2 to the power 12. Okay. And what they have done here for the most interesting part is the timestamp one. Before explaining timestamp, that data center, I think I made it clear it is 32. So it's 0 to 32 can be selected here, and in DB 0 to 32. And sequence is like to the power 12, it takes around, I think, 4096 maybe, or to the power 12, or 41096. Let me check. Google calculator doesn't comes to power when I need it. Yeah, 4096. Okay. So this much character it can hold. So what it does, it for every millisecond it reset itself for 0. So for 1 millisecond it can handle this much, 4096 values.
For 1 second.
Yeah, within no, for 1 millisecond. In 1 millisecond it reset itself to 0. It increment itself from 0 to this 4096 number in 1 millisecond. So there, if there are lots of hits within this 1 millisecond, it will excel. It can handle this much part. It will not repeat till this number 1096. If there is number more than that, if there are more requests within this in 1 millisecond, then only it get hampered. So that's why they kept that logic that after 1 millisecond we will start from 0. So 1 millisecond in 1 second it can handle this much numbers, that is around 4 million. Only sequence can handle 4 million within 1 second. Where is it gone? Where is it gone? That is the sequence generator. Okay. And what I explained, sequence generator can keep around to the power 12, that is around 4096 combinations per millisecond as it resets itself to 0 per millisecond after every millisecond. Okay. Now the timestamp. What is the magic of timestamp? What Twitter does, it saved one epoch of a machine, like a epoch machine is set, and I will show you the calculation of that epoch that they have taken. It is the time taken when the Twitter started, maybe. This is the diagram that I am seeing. Timestamp, data center, machine ID, and this is the sequence number. Okay. Sign bit is the first one that I have said. Na? It is 1 bit. It's kept 0. It is for future uses. Sequence number is 12 bit. The number is reset to 0 every millisecond. Data centers are completed. This timestamp, the timestamp that Twitter has taken, na, they named it as a snowflake Twitter approach. Okay. And this part is the timestamp they had kept. The default epoch is this one. This is a number, and if we derive this number, it comes out to be November 4, 2010. So it
On
started.
Google, on Google, I think we can convert this epoch to a human readable current date. Epoch to current date converter, something like that.
Okay, just give me a second. My power is out.
No, your power in a laptop power is out.
Yeah.
You are full of power.
Okay. So this epoch is the Twitter epoch. Let's find out how much it will say in Google.
Just write epoch after this number. Epoch convert to. No, America. It should be Asia, Kolkata, right? India, Kolkata.
Yeah, it's so no. Yes, you can see here it has converted it. It is America, right?
Okay.
Twitter is of America. So it converted to Wednesday, November 3, 2010.
ठीक है.
So this is the first one, and whenever the next calculated, it will get added to that one. Okay. So how they approach that? You will generate one ID here, random ID of this 41 bit, and you will convert this to a decimal number. Okay. You convert this ID to a decimal number, and that decimal number will be added to this epoch, that is default epoch. It will now bring another new timestamp, and that timestamp will be, if you convert it to the millisecond, it will be like there is a date. So what happens, this is incremental with the time. So every time if you want to sort the entries, you can sort it by this timestamp. So it will provide you the unique ID that is latest.
Yeah, it will always be unique because time factor is there.
Yeah, time vector is there. So this approach they have added in their time sequence, and there is one big calculation is there. Okay, the 2d power 41. Okay, it will come out around this much of millisecond. When we convert it to like years, it gives 69 years. So this 41 bit will be carry forward to next 69 years. After 69 years, they will only have to reset their epoch and clear all the unique IDs they have generated till now.
Zero is there, still there, na, for them after 69 years.
Sorry?
Zero is there at first character, na?
Yeah, 0 can be there. So if we use the one number there, then again next 69 years can be added.
Yeah.
That maybe that's why they kept that as a future. So this is the completion of UUID. It's very not very hard. So mostly they have kept this one for us. The snowflake was one of the promising one, but there are also issues in snowflake also that they have mentioned here a little bit. The DBs could be ahead of one another. So there are some mechanism to handle that is like named as NTP, Network Time Protocol. We can read about it in future if we need it. It's something like they will keep sync in between each other, the DVs, and whenever the other DVs goes up, it knows that it should get some halt, and it will like pause itself for some time, and whenever the number comes to the default one, it will start then generating. So these are like clock synchronization issue. It is another complexity that is in the Snowflake. So handling this is also costly. So that's why there are some solutions that came up. Like UUID has two different type of UUIDs are there. It is little bit expensive, but you can use it like it is 128 bit, right? So, but you can use it for different purposes. There are UUID 10, I think, and UUID 12, and those are detailed here. You want to UUID any idea? Yeah. So if you or you can check here. I have like in ChatGPT, what I did. Uh, I said it to compare between UUID versus Snowflake from NTP POV. So clock synchronization point of view. Okay. So it has breakdown in a different way. There are different version. Yeah, UUID V1 version. It is time based, so it has solved that problem of time stamp also. Like earlier, the UUID is, as I said, it is a integer one, not based on time. But this new version that is V1, it has solved it. Yeah, you can see here the comparison factors that depends on system clock. No, Snowflake is yes, and this new version of UID, yes, it is dependent. It is very sensitive to clock backwardness that I have mentioned, the clock synchronization issue. It mostly UID have covered all of those things, version 1. So that's why they have said that you can use when there are no space crunch, you can use UID version 1. Otherwise, Snowflake is one of the good solution for generating UID. Yeah. So that's all for this chapter, UID generation. Do you have any questions to me?
Okay, it was wonderful, really very insightful. Learned a lot. Yeah.
Good job, Kankan. Very nice.
Okay, thank you.
Thank you, KK. Thank you.
Okay.